So I'm Ryan McKern. I'm going to be looking at this a lot because I totally wrote myself a script and did not practice it at all. So we're just going to do this together live. I want to talk to you about Bash, and I want to talk to you about using dot files to configure Bash anytime you log into a terminal. I'm going to skim over some terminology and some history, and then we are... I lost my own notes. I'm going to skim over some terminology and history, and then we are going to do some short demos throughout it. Quickly want to point out that I'm going to have some links in here, and there's going to be some code on slides. If you are interested in either, I'm going to throw all this mess up into a GitHub repo after this, so you can check it out later. Don't like hastily scribble it down here or wonder like, why didn't he short link this? So, modern Unix clones like Linux and Mac OS are super ubiquitous nowadays. And despite almost 50 years of evolution, they're all ultimately derived from vintage AT&T Unix. That means that they've inherited the terminal as a first-class interface for connecting to the computer and making it do things. Because a computer that you can't make do things isn't very interesting. It's just a rock that burns electricity. So if we're using a terminal, that means that we're using a shell. A shell hides the details of the underlying operating system and manages the technical minutia of the operating system kernel interface. You can think of it as the lowest level between you and the computer that you can stand to work at. You can go lower, that's assembly. You can go higher, that's Java. You don't want to do either. So this quote explains one of the things that I think is great about the shell. The commands that you're running are interactive programming. You're writing shell scripts every time you use the terminal. So before I charge forward, I wanted to take a second to talk about interactive and non-interactive shells. An interactive shell is literally that. It's a shell that you are directly interacting with. The alternative is called a non-interactive shell, which is it's intuitive. It's probably the last intuitive thing you'll see in Bash. That's what runs whenever you execute a shell script like a command. Dot files don't get sourced by those. They're not run, and talking about how to make that work is probably out of scope for the short window of time we have together tonight. If you have questions about it, catch me on the break. I'll totally talk to you about it. So, what is a dot file? It's just a file whose name starts with a period. The period tells programs like ls to treat the file as a hidden file. This is a deeply old convention, and it's baked into almost everything in vaguely Unix-ish systems. Everything just assumes if it starts with a period, don't show it to the user by default. In our case, we're going to focus on some very specific files that start with periods that Bash will automatically look for when you log in or out of a terminal. So, Bash's dot files are shell scripts that are executed to change the environment of an interactive terminal before you start using it. That means that anything you can do in the terminal, you could therefore do in a dot file. This is the abridged dot file load order. There's a bunch of dot files that Bash will look for. This is basically the order that Bash uses out of the box to figure out which ones to load when. It's deterministic. It's always going to look like this, but it gets a little weird because depending on the operating system distro or the packages you might have installed on it, there may be other things that hook into this system and add new lines along the way. But broadly, this will always work. If you're not familiar with Bash or you've never read it before, this isn't pseudocode. This is actual live Bash. It'll work if you dump it into a terminal, but don't because it's doing all this automatically. In this context, source just means evaluate the code in this file in the current programmatic context. It's like calling require or include in other languages that you might be using already. So, we're going to talk about some things that you can do in Bash, and I'm hopefully going to remember to drop the terminal and do the demos for each of these slides. If I forget, shout at me. So Bash is an interactive programming language, and that means that one of the tools at our disposal is functions. Functions aren't quite as powerful in Bash as they are in other languages. They can only return true or false, and they can only emit output to standard out or standard error. That's it. That's all they can do. They can write to files, but for the sake of argument, this is all you can do with functions in Bash. But since they can emit output to standard out or standard error, you can capture that and interpolate that value into other places. That makes them useful for writing reusable snippets and tools. This example wraps up a bunch of common curl options. Specifically, silent, include, location, and head. These are the short flags. I'd prefer long flags, but only so much space in a slide. It runs that curl command in a subshell, and then it prints out all of the headers that are returned by the request. If you've ever had to maintain something like a packaging repo, then this is an invaluable function because you might be getting bad headers back. So let's see if this works. Hooray. Britt, is the font big enough? Oh, thank you. All right. So we are going to get that. There's our function. We've loaded it. It's available now. There it is. And we are going to run it. So, excuse me. You can see we hit DonutJS on port 80 with HTTP. We were redirected to port 443 for an HTTPS request. These are all of the headers that were printed out. This is a function. We could actually make curl load anything we wanted to at runtime as we start our session, but don't ever do that. That's terrifying. One of the other things that you can do with dot files is you can set environment variables. Environment variables are an extremely common way to configure lots of things beside your shell. If you've ever built a 12-factor style web application, you have definitely used environment variables to configure it. Unrelated, I don't know if anyone here has ever been to a place in New York called the Donut Plant, but it's one of my favorite donut places ever, and it seemed incredibly appropriate. These are real donuts at the Donut Plant. These are not real AWS keys. If you try to use them, hilarious things will happen, and you will not get donuts. So I don't know if anyone's ever taken a moment to actually look at their environment if they're using a shell to see how many environment variables are already defined, but it's way more than you think there are. Some of them are bash built-ins. Some of them are things that may have been laid down by the default system profiles that were there before you ever logged in. But we're going to take a look at just what that list is. All right. So most folks would do this by just running env and seeing what comes up. That's not a lot. That's really short. That looks like a reasonable number of variables. You could probably remember the name of all of them in your head. Cool. What's the harm there? But that's not the whole picture. Everything that just flashed by is actually what your environment looks like. So we're going to dump that to a pager. Yep. There we go. So right away, we already see a bunch of variables that we didn't see before when we called env. Did it detach? It detached. A moment. Let's see if I can get screen to reconnect. Yes. So glad I hacked in that reconnect button. How's that? Everybody see that? Cool. Thanks for the head shakes there. I appreciate that. New tool, first time. It's fine. So this is a bunch of variables that we didn't see before when we ran set. They just didn't show up. And some of these are bash built-in variables that determine how it works, and some of them aren't. But I'm just going to keep scrolling, kind of illustrate a point here. There's a lot of them. So what we're going to do is keep that in mind for the next round, because we're going to come back to variables. Using tools like this, you can change your shell behavior in your dot file. All of Bash's behavior is controlled with environment variables, set flags, and shell options. Shell options are set and viewed using a tool called Shopt, S-H-O-P-T. And I'm going to use that briefly, so you're going to see it in action. But they will change the way that the shell interacts. Get that back up. Oh, good, it's the right screen. So if anyone's ever used the command line on Windows and you want to change to a different directory, you just type the name of the directory and you're in it. It automatically moves to that directory. But on a Unix-ish system, if you do that, it just yells at you, because that's not a thing here. So we're going to make a directory. And we're just going to try to go to it, and nothing's going to happen, because it's not an actual command. So a moment. There's a shell option that you can check. We want a grep called AutoCD, and AutoCD will fundamentally change the behavior of the shell if you enable it. You can see here that AutoCD is off. So we're going to use Shopt. We're going to set it. -S sets the option. -U unsets the option. I want to, but the tool's not sophisticated enough. I will take the feedback on that, and I will get that prompt to the top of the screen, hell or high water. But we set the option. It does nothing. It doesn't return any feedback. I shouldn't say it does nothing. How's that? Top of the screen? Good? Cool. All right. Now, if we just type hello, the terminal interprets hello as CD hello. We've actually changed the fundamental behavior of the terminal. The interface itself has been completely altered with a simple flag. You could stick that in your dot file for any number of shell ops. Any number of shell ops. There's a bunch. I'll pipe that through less. There we go. Every single one of these will change the shell behavior in a meaningful way. I'm not going to tell you what all of them do. That would be terrifyingly boring. Get the terminal back to the top. All right. So we could take all of that here. We can stick that into a shell profile. I'm totally going to use Nano, not Vim. Come at me. It's fine. All right, so everything I just pasted into there is now actually part of the current running session. So that means that we should have an expanded path. And look at that. Opt donut bin is now at the front of our path because it loaded it from that file. All right, so I should dismiss the terminal. There we go. One of the other things that you can do with dot files, and this is probably what's going to take us the longest because this is a terrible process, is changing your prompt. The prompt template is defined using an environment variable, just like most behavior in Bash. This means that we can use all of the tricks that I've just talked about in the slides previous to make a functional, better-looking prompt than what Bash has out of the box. This is probably the most useful thing that I'm going to show you tonight, but it's also the gnarliest because we're going to be using something called prompt escape sequences. They're not intuitive. They are Byzantine and weird. So these are common prompt escape sequences. This isn't nearly all of them, but these are the ones you're most likely to see and probably the ones that you care about the most in your prompt. The escape sequences themselves are conceptually like another kind of variable that Bash will only interpolate in the context of the process or the prompt template variables. The user manual for Bash has a complete list. There's a lot more than this. And most prompt generator tools that you can use will expose all of them. So don't feel limited if you see one that looks cool, but you've never seen anyone use it. By default, the most common ones that you'll see in a default Bash profile are /s and /v. They're not on this list because it's only in the default profile. They expose the name of the running shell and its version. That's not useful. That doesn't tell you anything about where you're at. So we're going to try and build a prompt that's more useful than this. And we're going to have to do this with non-printing characters. Non-printing characters really means send terminal control commands directly to the terminal instead of rendering them. And it's how we get color into our prompt. They're arcane because they date to a very different hardware era when we still used clunky hardware terminals to connect to a centralized Unix computer located somewhere else. Since they're arcane, what most folks do is use a tool like the command tput, T-P-U-T, to generate a list mapping those codes to more meaningful variable names. I'm going to use a pre-generated list of those tonight, but it's going to be online. You can reference it, you can build your own, totally straightforward. So this is a part where I am going to build a new PS1 with you interactively. Let's see how this goes. All right, so we have a new shell. I'm going to start a new login shell. Bring that back up to the top. Okay, so I have pre-staged some files in my home directory, which I was not in. One of them is the color map. And it just looks like this. We're calling tput, we're feeding it some weird stuff that doesn't make any sense to a human being, and we're saving it to a name that we can use later on. I've left myself some comments so that I can see what each of these colors should be. You can see I've got regular fonts, bold fonts, underlined fonts, and a reset that just brings everything back to the way the terminal was before we called any of these. These are the basic building blocks of a colored prompt. So we are going to source.colors, and we are going to do that in our bash profile. So we've added that line, and we load it. Then we check that it's actually there. Great. There's some terrible command codes for colors. And you can see what I mean about arcane. Who could actually tell me what those prompts do, realistically? No one. No, it's lost art. So, a moment. I'm going to open up the bash profile again. And I'm totally going to just paste out of my own notes here because I don't remember these codes. No one does. And we're going to set the default prompt so I can show you what that looks like. That is the code for the default bash prompt. /s-/v and $. I know I'm running a little bit low on time, so I will try to move it along. But we've changed the basic prompt to that. That's, it's there. It's a thing. It looks okay. But this is going to print out much more useful information. It's going to do it with some greens and some blues. It's going to look great. There we go. That's a much more useful prompt that you might actually enjoy staring at part of the time. If I were doing a little bit better on time, I would show you how to do neat things like getting the status of a Git repo that you're currently in into your command line. But I'm already kind of over to the tune of about 2.5 minutes, so I'm going to wrap it up. Before I go, these are some tools that will help you do stuff like this without having to remember all kinds of arcane Unix minutiae. Since Bash is a programming language, there's a whole wealth of programming tools for it. These are some of the tools that I used while I built this. Shell check is a static analysis tool for shell scripts. If you're not using it, I highly recommend it. It's great. Easy Prompt is an online drag and drop PS1 editor. PS1 is the name of the environment variable that you use to set your prompt. Since it's a drag and drop, you can see what it's going to look like before you ever actually make it. It's a really easy way to fine tune. Sensible Bash is a bunch of defaults that you can load into your profile that will give you a sane working environment every time you log in. Bash It is a port of Oh My Zeesh, which everybody who uses Zeesh raves about. I don't use Zeesh, so I don't care. And the Bash Wiki is a deep reference source for Bash. If you're looking on going really down to the metal in shell scripts, It's an invaluable resource. You'll spend a ton of time there because someone will have documented all of the weirdness, quirks, hiccups, arcane behavior, and legacy WTF-ery that you might encounter. And that's that. Yes, the image is the right size. I'm so excited. It was huge earlier in demos. So thank you for coming. You're great. I hope you enjoyed your donuts, and thank you for having me.